Here we're going to continue looking at translations of functions, so shifts, left, right, and so on. So number 3, sketch the graph of the quadratic function and the axis of symmetry. All right, so we're going to graph the sketch and the axis of symmetry, and then state the vertex and give the equation for the axis of symmetry. So we have the function h of x is equal to x plus 1 squared. This is in the form a times x minus h squared plus k. All right. This is important to note it because we're going to see this a lot and it's going to give us a lot of information. This is called vertex form. And what vertex form tells us is that our vertex is hk and my axis of symmetry is x equals h, okay, whatever the h value happens to be. So we want to note that vertex form gives us the vertex and the axis of symmetry, which is what we're looking for in this problem. So it'll make our lives a little bit easier. So here, this plus 1 is going to be my h value. This tells me that my graph is going to shift. It tells me a horizontal shift. It's backwards. So instead of being plus 1 thinking right, it's actually going to go left. So our graph is going to shift left 1 unit. Now, what are my values here? I don't really need to worry about a in this case. There is no a. But h is equal to, all right, we have a plus 1 there. But remember, or be careful, the formula is minus. So we have a plus, so that means h is going to be equal negative 1. And k in this problem, well, we're looking for what's over here. If we were to put something there, it would have been plus 0. So k in this problem is 0. So first thing I can state, my vertex is hk. So remember hk. So that tells me my vertex is going to be negative 1, 0. And then my axis of symmetry is equal to x equals h, which tells me that the axis of symmetry is x is equal to negative 1. Right, so we want to graph this. We need to kind of find some points. We need to plug some things in. There's a couple things you can do here. I mentioned this in the last video. You have your standard numbers, your standard x values of negative 2. I'll write these down on the bottom here. So usually negative 2, negative 1, 0, 1, and 2. However, we have a shift horizontally, so it's going to go left 1 unit. So I need to adjust these numbers. I need to subtract 1 from my standard ones of what I'm going to use. All right, so negative 2 minus negative 1. I'm going to use negative 3, negative 2, negative 1, 0, and 1. All right, and those would come from here. Again, I've mentioned it before. It's a little tricky to get used to, but you'll get used to that. Use your standard negative 2, negative 1, 0, and 1 and 2. And then anytime there's a horizontal shift left or right, those numbers, your x values are going to change, and that'll be based off of what your horizontal shift is. So in this case, it's a left 1, so we're going to subtract 1 from everything. All right, now next, we are going to take these numbers, I'll color my highlight. These numbers here are going to get plugged in as our x value, and then we're going to find the y values. So negative 3 plus 1 would be negative 2, and then we want to square that, so that's going to be 4. Negative 2 plus 1 is negative 1, squared would be 1. Negative 1 plus 1 is 0, 0 squared is 0. 0 plus 1 is 1, 1 squared would be 1. And then 1 plus 1 is 2, 2 squared is 4. What should happen if you've done this correctly? All right, so if I've picked the right x values, these two, the first one and the last one should match up, and these two, the second and the fourth. All right, that's if you're following the standard numbers that we usually use and you've made the correct adjustments. So now I'm going to plot these points. I have negative 3, 4, so that's going to be up here. Negative 2, 1, negative 1, 0, 0, 1, which is perfect because now my graph should be switching on this side. and then 1, 4. So here I have a parabola. Remember that it's squared, so it should look like a parabola. All right, so sketch the graph. All right, sketch the graph, we can check that off. And the axis of symmetry. Your axis of symmetry is x equals h. We said this right here. So again, this is my axis of symmetry. So right where x is equal to -1 is right here. I'm going to put a dotted line representing the axis of symmetry. Our axis of symmetry should always be a dotted line. It should always go through your vertex. All right, if your axis of symmetry doesn't go through your vertex where your graph changes directions, then something has been done incorrectly. All right, so we graph the axis of symmetry and then state the vertex and give the equation for the axis of symmetry. We've already done that. That was our vertex right here and our axis of symmetry here. All right, so hopefully that kind of clears that up. You'll get used to this. You'll see this quite frequently with quadratics, with absolute values, things like that. Tends to happen pretty often. All right, so let's take a look at number 4. In number 4, we're told to graph the function f of x equals x squared plus 1 as a translation of g of x equals x squared. Right, the nice thing about this is this one should actually be easier than the last one. So f of x is equal to x squared plus 1. This plus 1 tells me that there's a shift up one place. All right, because that plus 1 is outside of the parentheses or the absolute value or the brackets. If I go back to number 3, that plus 1 was inside, so that was my h. It determined shifts left and right. My k value is the one on the outside. All right, so in this case, k is equal to 1. That tells me that there's a shift one place up. So the nice thing about shifts up and down, or vertical shifts, is my standard numbers do not need to be changed. I can still use -2, -1, 0, 1, and 2. So we'll plug each of those in. We're going to take these 5 numbers, plug them in for my x value, and find a y value. So -2 squared would be 4. 4 plus 1 is 5. -1 squared, 1. So that's going to be 2. That'll be 1, 2, and 5. Now, again, I mentioned this just before, but these two, the last and the first, should match up, and then the second and fourth should match up if you are using the right x values. Okay, if you're following kind of the plan that I'm suggesting, the -2, -1, 0, 1, and 2. All right, if you do that, those numbers should match up. So we're going to plot our points. I'm just going to move this over a little bit. -2, 5. So -2, 5 would be up here. -1, 2. 0, 1. 1, 2. Which is good. Again, we're seeing that curve in the parabola now, and then 2, 5 would be up top here. All right, so connect these. Get a little sketch of our curve. Again, not perfect, but it's going to do. And that's all they're asking us to do. Graph the function f of x equals x squared plus 1 as a translation of g of x equals x squared. So the x squared, that original one, I'm just going to draw a quick little sketch of where that was. That original one, all those major points were one place lower. All right, so you had an original that was here and here. And what we did is we shifted that graph. That graph went up one place based off of that there. All right, so hopefully that makes sense, and give the practice problems a try and see how you do.